All right. I'm gonna put my glasses on. So the first term that came up was evaluate. And when we're asked to evaluate something, it just means to figure out or interpret something. So we'll give you an expression or equation, and it might ask you to evaluate it for something. Okay? Here's an example. Oh, can you please evaluate the function of n equal to 2n plus 4 for a function of 3? So here's our function, and we're asked to evaluate it for f of 3. So if I were to do that, I would just substitute 3 in for our n. So f of 3 equals 2 times 3 plus 4. 6 plus 4 is 10. So the function of 3 would be would equal 10. Anyway, that's what evaluate means, okay? Substitute also came up when I asked questions about the quick start guide for the functions. And substitute just means to put in place of or to replace with, okay? So for example, in the example above, in this problem up here, when we substitute the value of 3 for n, we get 10 for the function of n. So that's what we did here, is by dropping this 3 in for n, we substituted, okay? So indicate. Indicate is just a verb that means to show or to tell me or to name or explain, okay? For example, I might ask a question like, in the following graph, indicate where the domain of the function is less than or equal to 3. Okay? So I might ask you to indicate something. It means to point out or to show, to point out. That's another good one. Okay, a function, that's just a relationship between a set of inputs and a set of outputs. That's all. It's a relationship between x's and y's, or inputs and outputs. But the key is that every single input you have, like let's say I put 2, 4, 3, 5, every single one, x has exactly one output. There can't be more than one or a different one. And I'm going to explain that later. Oh, this relation, y equals 2x plus 2, this is a function. Because for any number you input for the x value, you're going to get some specific output. Okay? And then function notation is just a way that we express the output of a function using this notation f of x or g of x or f of n or whatever. It's just a function of that thing. Okay? So we're going to see this this type of expression or this type of equation a lot, especially here in the first semester when we start graphing lines. Okay? This is y equals 2x plus 3. This is fine. This has an input and an output, right? An x and a y, and you could make a table and you could make a graph, right? But it's not function notation. Function notation is when instead of using y, we use f of x. It's just like having two different names. The same math is happening here, but like this one's called Jose and this one's called Gudelio or something. It's just different names, this here. So don't get tripped up by that. Sometimes you're going to see y, not function notation, and sometimes you'll see function notation, okay? Just keep in mind that, function of x, that's a different name for the equation, okay? Okay, deep breath. Now we're going to practice a little bit. So again, notice the language that we're using here. This is on the back of the paper, by the way. And like, for example, it might say evaluate the function for the given input value, where it says g of x equals 3x plus 4, and then it's asking, well, what is the g of negative 2? Well, we're going to substitute it. So we have g of x equals 3x plus 4. So the g of negative 2 just means we're going to drop negative 2 and substitute it for x. And remember, when these letters and numbers are adjacent, that means they're next to each other, it's multiplication, okay? So like 3, and then instead of x, we're going to substitute negative 2, and then bring down the rest, plus 4, okay? 3 times negative 2 is negative 6, plus 4. Negative 6 plus 4 equals negative 2. So that means that g of negative 2 is negative 2. So if we were going to put this on a graph or something, the point, negative 2, would be in our solution. Okay, here's how you might see this other language. Let's try the second problem. Oh, please indicate the domain and the range of the function at the right. Okay, well, we're going to indicate the domain and the range. The domain, those are all of the x values. So how much space is covered by the function side to side? That's the domain. So what we do is we identify where the function starts and ends. So like, do you see how it ends right here? And then also right here. So this distance between the two post-its, this is the domain from here to here. Okay? And the way that we express it is it's our x value. And we say that our x is in between. And the way that we show this is by doing x is greater than or equal to, or x is less than or equal to. These are the symbols that help us say that the x is in between. Now, which one's all the way to the left? So let's go all the way to the left. And the leftmost point here is when x is negative 9, right? And then when we go to the positive side, the greatest most x value is 7. So what we could say for this problem is that the domain is negative 9 less than or equal to x less than or equal to 7. That's our domain of this function because it's in between both of those. Okay? Now let's do the range, but let's do that with a different color. So the range, that's like all of the y values. Like how much space does it take up, top to bottom, not left to right. So the range is the y value. So when everyone's like, oh, what's the range? Well, you got to find the uppermost point. Watch what I'm gonna hit as soon as I hit my function. This is my function. And boom. See how it hits right there? Okay. And then also down here, look. Look at my blue line. I'm still below it, still below it, still below it. Bam, right there is where my range is. So the range of the function is between these two y values. So the way that we express it, like this. The domain, we have our y value. That's our up, down, north, south, or vertical axis. It's in between. So it's greater than something and less than something else. And we said, where is its low point? We said it's at negative 6, so that goes first. So negative 6 is less than or equal to y, is less than or equal to, now what's the high point of the function? It's up here at 4. Okay, so we got these two things. This shouldn't say domain at all, it should say range. Oops. So for this function right here, the domain, or the x values sideways, our domain is from -9 to 7. Our x, all of these x values, is in between -9 and 7. And our range, our uppermost point that it hits to our lowermost point, is in between -6 down here and then 4 up here. So our y is in between -6 and +4. I think we're good there. Okay, I'm not going to take on problem 3 right now. I'm just going to leave it right there.